Thank you for being here.
Thank you very much for having us here today, Steffi. It's been a long 2 years without DLD, although we have a DLD sync, but I really missed the chit-chat in the corridors, the sporadic encounters over coffee, and the inspiring people you meet here. And nobody is better at bringing people together in the way that Steffi does. No algorithm in the world can do it. And fortunately, today we are having the best of both worlds here because we get to have the sporadic encounters and the chit-chat that we've been missing for so long. But we're also having the possibilities being offered by hybrid formats, which allows us to get access to really smart and brilliant people wherever they are. And yes, I am referring to Azeem, who's joining us from London today. It's really good to see you, Azeem, and I can only echo what Steffi just said about your newsletter. Everybody should sign up for it. And I was really delighted to see some commentary on a piece I wrote a while ago in your newsletter recently, which also forms some of the content for today's conversation, which I must say follows up really well on what we heard from Axel Voss in the previous session. So I don't know if you had a chance to listen as well, Azeem, but good to see you, and over to you.
Well, Carl, thank you for that wonderful introduction. And I'm sorry I can't be there in person. My daughter has an induction for her new school, which is taking place, and I wanted to be around for that. But I did, in advance of our conversation, pull out one of my favorite books on issues of automation and AI, which is this one, The Technology Trap by Carl. Steffi pitched my book, which comes out in September. But until then, I do strongly recommend people read Carl's book, which is really fantastic, scholarly, wonderful read into automation and its impacts over the past couple of 100 years. And you know, I was thinking a little bit about why we were brought together. It was to do with that that discussion you had with Tom Davenport about whether China really has a lead on the US or could have a lead on the US in AI, and what how that strategic balance might play out. And I guess the traditional argument is that China can get very, very well organized. It can leverage lots of graduates. It can leverage lots of large companies. It can get a ton of data from, Didi and Alibaba and Pinduoduo to train AI systems on. And that combination, together with a state-directed capability to build great artifacts like high-speed rail or high-voltage lines, creates a combination that will give them some sort of lead in developing AI that will be hard for the more decentralized US economy to ultimately catch up in the medium term. And you had a rather different take on those advantages. Could you just reprise what your take on that was?
Sure. So I think the question you just raised is one of the key questions of our time, right? We do see this extraordinary rise of China beginning in 1978, and growth has seemingly, accelerated for the past 40 years. We see it being on a bit of a plateau these days. But really, if you look at the frontier of what's happening in 5G and artificial intelligence, China is making enormous strides, and there is no question about it, that we should definitely not be complacent, right? But at the same time, I think there's a real risk of exaggerating China's AI capabilities. We heard from Axel Voss earlier that Europe is taking a very different approach, where it pays a lot more attention to data privacy, to individual rights, to the role of democracy, even in a data-driven economy. And I think there's a narrative out there that these two things are incompatible, that you cannot be a leader in artificial intelligence while at the same time maintaining data privacy and individual rights the way we know them in Europe and the Western world. And I think this is a somewhat unfortunate narrative for a number of reasons. First of all, you sort of alluded to China's alleged data advantage. You often hear notions that data is the new oil and China is the new Saudi Arabia of big data. And there is some truth, at least to the latter part, but I think it's important to remember that data is always domain and context specific, right? You're not going to make huge advances in autonomous cars by assembling large data sets on people's faces. That helps for developing surveillance technology, but it doesn't help you for developing artificial intelligence that is better at diagnosing cancer, that is better at driving progress in driverless cars. So data is not the new oil in the sense that it can only really be used for the purpose for which it has been collected. And I think that is really important to keep in mind. Yes, China may have an advantage when it comes to surveillance technology, but artificial intelligence is much more than that.
So I think we could both agree on that point, that data is domain specific. And what I would add, though, is that when we look at other domains of activity, for example, health data, because of the larger scale of Chinese hospitals and municipal hospital systems than you see in US systems, there is often much more availability of chest scans, CT scans, MRIs for researchers. And when I remember a few years ago being involved in diligencing a Chinese AI startup which had essentially got access to all of the chest scans in the Shenzhen and Guangzhou area, which was about 12 million people worth of scans. So outside of facial surveillance, you were seeing it in health data, and you also see it within self-driving as another example you gave, because regulators have much more flexibility around where they choose to have experiments and where they allow these experiments to take place. I remember back in the days before COVID, where I could travel and meet people, speaking to a senior Chinese regulator who said to me, well, our approach to regulation, and she used a phrase which I will clarify, is let the bullets fly, by which she meant we'll allow the experiments to take place, and if we find they're causing harm, we can step in pretty quickly because we have a very rapid mechanism for that step in. So I agree with you that data is context specific, but I do think that that China does have access to lots and lots of data and a regulatory framework that allows that to happen in many, many different places. But I'm not sure that necessarily gets us to the place where we say, well, China's therefore ahead. I mean, I think one of the arguments you made very compellingly was that you're not even sure whether having lots of data in a specific domain does necessarily mean you get a long-term advantage.
Yeah, thank you for raising that point. And I think one of my favorite phrases in the article, which I co-authored with Michael Osborne a while ago now, is that if data is the new oil, then it might well be China's natural resource curse. So, I mean, think about 1900, right? We have gasoline-powered cars. We had electric cars. They're essentially on par. 10 years down the road, huge oil discoveries are made, tips the balance in favor of gasoline-powered cars. 100 years down the road, we are now trying to get back into electric cars. And I think there is a case to be made that this huge abundance of data could potentially lead to a kind of lock-in in really data-intensive approaches to artificial intelligence. And when we speak about artificial intelligence, I think it's important to remember that it has many very different subfields, right? So back in the 80s, symbolic AI dominated with expert systems where you essentially try to sort of pre-specify what the technology should do at a given contingency. Today, we are very much sort of the balance is tipped in the favor of deep learning, which is hugely data intensive. And I think most researchers in the field are gradually coming to the view that you need some sort of fusion between the two, right? Some marriage of deep learning and more traditional approaches to artificial intelligence to get an understanding of how the world works, right? For those of you who can see the table over here, right, we can get an algorithm to predict that there are glasses and bottles of water standing on the table. But the algorithm would have no conceptual understanding of how those objects relate to each other. It's pure statistical approximation. And I think in order for us to get somewhere in the field of artificial intelligence where it begins to have a real impact also on the physical economy, what we need is more innovation for technologies to be able to learn also from smaller data sets, right? The way that small kids learn, right? Kids learn from very, very small data sets. Artificial intelligence, you need millions and millions of trials. But you don't have that in the physical world, right? It's fine to run millions of trials to play the game of Go or to play some Atari game. But if you want to teach a robot to empty your dishwasher, you're not going to be able to run a millions of trials. You will have broken dishes all over the place, right? So I think the question is, in the sphere of artificial intelligence, when we want to assess, and if we want to assess who is likely to lead in this particular domain, we should ask ourselves the question, who is most likely to come up with the critical innovations that lead to greater data efficiency in the field of artificial intelligence? And I would admit the answer to that is not entirely clear, but it's a very different way of framing the question surrounding who's going to lead in the field of artificial intelligence than thinking that just assembling larger data sets and the continuation of Moore's law is going to do the job for us.
Yeah, I love the way that you frame that question, and I think we don't yet know the answer, but maybe I can provide some context as to why we may feel a bit pessimistic of the progress that's been made so far. If you look at what's happened with the agglomeration of AI talent and AI investment within the largest American companies, the big five, they're demonstrating a very significant brain drain where machine learning and AI professors are moving from free-flowing academia into tied research within the corporate context. There was some very interesting research from Nesta, which is a UK agency, showing that the breadth of research, of machine learning and AI research that comes out of those top companies is extremely narrow. It's deep learning and flavors of deep learning applied to increasingly narrow applications, as opposed to new paradigms of the type that we think we need. And then if we looked at smaller companies, there's additional research that shows that when venture capitalists tend to back emerging technologies, those technologies tend to narrow in their scope of application and their degree of innovativeness because the capital that's applied wants a return reasonably quickly. Now, what I've just described is essentially the industrial economy of the AI industry in the US. On the one hand, the very big five companies, and on the other hand, a slew of venture-backed startups, none of which point to really the basic research that seems to be required to derive a sort of data-minimized AI scheme. And I would follow that up by just to bring on your analogy of the gas car versus the electric car. The reality is that very large models are working in the sense that they are making money for the people who back them. And that has created an entire vertical supply chain of people committed to large models. The GPT-3 model has 175 billion parameters. Google and Microsoft have even bigger models. Because these models are so data intensive, companies are developing chips like Cerebras that are high data bandwidth chips just designed for processing these models. And those are the chips that are being put into the data centers. So it's a little bit like, well, the gasoline car comes out, and then out come the petrol stations, and out come the mechanics who know how to change carburetors, and the infrastructure that's required for the electric car doesn't show up. So there's some really interesting, powerful momentum around exploiting this data-based approach to AI. And so one question for me is, where can we turn to? Is it DARPA? Is it the new UK agency ARIA? Or is it going to be academia, where the bets can be taken to help us find this new paradigm that you describe?
Yeah, so first of all, I love the way you phrased that, and I think you said it much better than I ever could. But I think there is also a very profound point in there, is that if we see that the companies that are leading in artificial intelligence are engaged in this premature narrowing down on deep learning, which I think is premature, because artificial intelligence, I think it's important to remember, is not a mature technology yet, right? For the reasons we previously discussed. We need more innovations for it to become increasingly data efficient. And to give you another analogy, right? The reason why we think of James Watt as the inventor of the steam engine rather than Thomas Newcomen, right, is that James Watt developed the separate condenser that made the steam engine energy efficient. Before then, steam engines were merely used to drain coal mines, and even that they didn't do particularly well. And the same can be said with artificial intelligence today. And I do think it's a real role here for governments to play in diversifying the bets that are being put on different approaches to artificial intelligence. There's no reason to believe that the market should get it right every time, at least not in the short run. And we can get into this lock-ins, as we discussed with the gasoline-powered cars earlier. So what to do? Well, we do know that grants made by the National Science Foundation, for example, have a very positive return. The same is true of Horizon 2020 in Europe. Government funding can be used to sponsor different approaches to artificial intelligence than are currently being undertaken by the leading tech companies in the United States and China. And I think there's a real opportunity for Europe to play a significant role here, right? The AI race is in its very beginning. And if Europe decides to take a different route and put a different type of bets and diversify more, there's still a lot to play for. And what most of the evidence suggests is actually, if you look at who tends to come up with the most disruptive foundational innovations, it actually tends to be often single inventors or smaller teams. If you fund a very large organization or a very large team, they often feel pressured to move towards the consensus view, right? You're less likely to come up with a really crazy idea and put it to a lot of people you don't know than, being in a small group and arguing for pursuing an unconventional hypothesis. So I think we need to partly move away from this overwhelmingly funding these huge projects with 20 universities all across the world, and rather focus supplementary on smaller teams. It's not a question of doing one or the other. Both is important, but I think there's been overwhelming focus on the larger, more sort of cross-disciplinary teams in recent years. So to really sort of reshape the AI landscape, betting on smaller teams, pursuing unconventional approaches to artificial intelligence, in my view, is the way to go.
I mean, it's interesting because we have a fabric that allows smaller teams to do much more than they were previously able to do. And when you started to talk about smaller teams, I was thinking really about all the contributions on GitHub, right? The open source contributions that are now possible. And the fact that breakthrough AI is, in a sense, harder to access now than it was 3 or 4 years ago, because the frontier of where the breakthrough is tens of millions of dollars of processing time and a lot of data. So we have this opportunity to take advantage of the internet being deployed everywhere and distributed tools that allow people to collaborate even in their small teams remotely, which is something that perhaps we didn't have as much a decade ago. And then I think the question then becomes, how do those teams get their funding, and how do they get the safety, the protection from the market that allows them to actually continue to develop? And I think one of the things that I struggle with, Carl, here is the extent to which at this phase in the sort of the super cycle, right, of the internet is deployed everywhere. If you write a piece of code, you can get it in front of millions of people. Is this the phase at which actually pragmatic entrepreneur engineers tend to do all of the running, compared to the earlier phase when it tends to be innovators and risk takers, and that perhaps we have to just accept that the next 10 to 15 years is really, to use the phrase of the economist Carlota Perez, the deployment phase of these technologies, and we just live with it, and there's not much we can do.
Yeah, so I mean, I think the recent episode of the COVID-19 pandemic and the route to the vaccine is illustrative here, because if we think it's about innovation and technological progress, artificial intelligence is no different really than many other technologies. How did we get to mRNA vaccines? Well, there was a very long process that happened over many decades. Carrico and Weissman sporadically met at the Xerox machine, decided to collaborate. They produced a paper in 2005, which didn't have very much impact at the time. Another guy named Rossi came across it in a different context. And it was something that, spread from one team to another. Eventually, it became developed as a vaccine that is being possible to mass produce on huge scale. So you went from having these sporadic interactions, smaller teams, small group of people pursuing a very unconventional hypothesis, towards smaller companies like BioNTech and Moderna being able to turn this into a commercial product, and then in turn entering to private partnerships with companies like Pfizer to scale up and deploy the technology on a mass scale. In my view, when it comes to artificial intelligence, we are still in this more exploratory Carrico-Weissman stage. When it comes to certain domains, clearly the technology is more advanced, and it is to some extent a question of scaling up, which is also one of the reasons why Europe has been lagging behind in this particular domain, right? We don't have the huge internal market for services where cultural content and language content matters a lot, as the United States has with an internal market of 300 million people and the English language, right? There's a reason that Finnish films are not particularly popular in Portugal, right? And we still do have this fragmentation in Europe, which is a strength to some extent when it comes to innovation, but also a deficit when it comes to scaling up.
Carl, I just saw a message saying that we have to bring our conversation to an end, which is a real pity because there's so much more to discuss around the great AI game. But you talked about the nature of finished films, and I leave you with the thought that perhaps these mainstream deep learning models that are doing a really, really good job of translation, amongst other things, might allow those finished films to find a market in Portugal sometime soon. I've really enjoyed chatting with you today, and thank you for bringing me on this big screen.
Great to see you, Azeem.
Thank you.
Okay, thanks.